Ever pondered about the universe and its genesis? Welcome to an exploration of its creation from nearly 14 billion years ago. The Big Bang Theory. But it's more than just an immense explosion. It's a cosmic saga about how the universe we know today was knitted together. But what evidence backs this grand claim? How were these cosmic secrets unveiled? Are you intrigued about our place in this vast cosmic puzzle? Let's embark on a journey, transcending space and time, to revisit the birth of everything. Fasten your seatbelts, we're about to demystify the Big Bang. Imagine everything you see, all matter, all energy, all space and time, condensed into an infinitesimally small point. This is the concept at the heart of the Big Bang Theory, the leading explanation about how the universe began. At its simplest, the Big Bang Theory proposes that the universe as we know it started from a singularity, a point with infinite density and temperature. Picture a dot so small that it's impossible to see with the naked eye, yet so dense that it contains everything that will eventually become our universe. But this singularity didn't just sit there. Around 13.8 billion years ago, it exploded. Not like a typical explosion you're used to seeing, but an explosion of intense heat and density that began to expand at an incredible rate. This is where the term Big Bang comes from. In less than a second, this expansion produced a flood of particles. Quarks, electrons, photons, neutrinos, the fundamental building blocks of the universe, were all created in this initial burst of expansion. And the universe didn't stop there. It continued to expand and cool. Over billions of years, these particles came together to form atoms, then stars and galaxies, leading to the complex universe we see today. So, if you ever look up at the night sky and wonder about the vastness of the universe, remember that it all started from a tiny, dense point of singularity. And it's still growing, but you might ask, how do we know all this? If the Big Bang happened billions of years ago, how can we be sure that's how our universe began? It's a valid question. After all, no one was around to see the Big Bang. But that's where science comes in. The Big Bang Theory isn't just a story. It's a theory supported by a myriad of scientific evidence. So the universe as we know it started with a small singularity, then exploded and is still expanding today. But how do we know this? Stay tuned to find out. Believe it or not, the proof of the Big Bang is all around us. The evidence is woven into the very fabric of our universe, whispering to us the tale of its fiery birth. It's like a cosmic detective story, with clues scattered across the vast expanses of space and time. Let's begin with one of the most compelling pieces of evidence, the redshift of galaxies. This phenomenon was first observed by Edwin Hubble in the early 20th century. As he peered through his telescope, he noticed something peculiar. The light from distant galaxies was shifted towards the red end of the spectrum. This redshift happens because the galaxies are moving away from us, their light stretched out as they recede. It's akin to the Doppler effect, where a car's engine sounds different as it approaches and then speeds away. This cosmic redshift is evidence that the universe is expanding, and if we wind the clock back, all of this expansion points to a single origin point, the Big Bang. Next on our evidence list is the abundance of light elements. Early in its life, the universe was a hot, dense soup of particles. As it cooled, these particles began to combine to form the first atoms. The theory predicts that hydrogen and helium should make up the vast majority of these early atoms, with trace amounts of lithium and beryllium. And when we look out into the universe, that's exactly what we see. The proportions match our calculations almost perfectly, a testament to the Big Bang's accuracy. Our final piece of evidence is perhaps the most remarkable, the cosmic microwave background radiation, or CMBR. It's a faint echo of the universe's early moments, a snapshot of the universe when it was just a few 100,000 years old. In 1965, Arno Penzias and Robert Wilson stumbled upon this cosmic afterglow quite by accident. They were trying to eliminate static from their radio antenna, but this persistent noise coming uniformly from all directions simply wouldn't go away. It turned out this noise was the CMBR, the oldest light in the universe. Its discovery was a monumental moment, solidifying the Big Bang Theory as the best explanation for our universe's origin. These pieces of evidence, from the redshift of galaxies to the abundance of light elements and the cosmic microwave background radiation, all paint a consistent picture. Each clue corroborates the others, reinforcing the narrative of a universe born from a singular explosive event. They tell us that around 14 billion years ago, all matter, energy, space, and time emerged from a state of infinite density, setting the stage for the cosmic drama that continues to unfold. These pieces of evidence strongly suggest that the universe had a definite beginning, a moment of creation. The Big Bang is more than just a theory, it's a story written in the stars waiting for us to read. Like any scientific theory, the Big Bang Theory has faced its fair share of skepticism and challenges. The Big Bang Theory, despite being a widely accepted explanation for the origin of the universe, is no stranger to misconceptions and challenges. Some of these misconceptions arise from a simple misunderstanding of the theory itself. For instance, many imagine the Big Bang as a colossal explosion that happened in a specific place and time. However, this is not the case. The Big Bang was not an explosion, it was an expansion of space itself. It didn't occur in a specific location within the universe, but rather, it was the birth of the universe itself. Another common misconception is that the Big Bang Theory contradicts the second law of thermodynamics, which states that systems naturally evolve towards a state of maximum disorder. Critics argue that the evolution of the universe from a state of high disorder after the Big Bang to its current state of relative order contradicts this law. However, this argument overlooks the fact that the second law applies to closed systems, and it's not clear that the universe is a closed system. The Big Bang Theory has also faced challenges from alternative scientific theories. One such rival is the steady-state theory, which proposes that the universe has no beginning or end and is infinitely old. This theory suggests that new matter is continuously created to maintain a constant density as the universe expands. However, the discovery of the cosmic microwave background radiation, a relic of the early universe, dealt a significant blow to the steady-state theory and provided compelling evidence in favor of the Big Bang Theory. The Big Bang Theory has evolved over time in response to these and other challenges. For example, the initial theory couldn't explain why the universe appears to be the same in all directions, a property known as isotropy. This led to the proposal of cosmic inflation, a brief period of extremely rapid expansion in the early universe. Cosmic inflation not only explains isotropy but also resolves several other problems with the original Big Bang Theory. Another challenge was the mystery of dark matter and dark energy, unseen forces that seem to dominate the universe. The Big Bang Theory has adapted to incorporate these mysterious entities, further demonstrating its resilience and flexibility. The Big Bang Theory, like all scientific theories, is not a fixed, unchanging dogma. It's a dynamic, evolving framework that adjusts and grows in response to new observations and discoveries. It's a testament to the self-correcting nature of science, where no theory is above challenge, and all theories are subject to revision in light of new evidence. Despite these challenges, the Big Bang Theory stands strong, continually adapting and evolving with new scientific discoveries. The Big Bang Theory doesn't just explain how the universe began, it also gives us a perspective on our place in the cosmos. This theory, in essence, has fundamentally altered our understanding of the universe and our place within it. It's akin to a cosmic GPS, providing insights into where we came from, where we are, and where we might be heading. From the Big Bang Theory, we've gleaned that our universe began as a hot, dense point nearly 14 billion years ago. Since then, it has been expanding and cooling, leading to the formation of galaxies, stars, and planets, including our own. This implies that we are not separate from the universe, but an integral part of its grand narrative. We are, in essence, stardust, made of the same elements forged in the fiery hearts of long-gone stars. Furthermore, the Big Bang Theory enables us to predict the future of our universe. If the expansion continues unabated, our universe will continue to cool and spread out, eventually becoming a sparse, dark, and cold place. On a cosmic timescale, everything we know, our planet, our galaxy, even ourselves, is transient. Yet this realization should not lead to despair but rather a profound sense of awe and humility. It underscores the fact that we are tiny specks in an incredibly vast cosmos. A cosmos that existed billions of years before us and will continue to exist billions of years after we're gone, but for this brief moment in cosmic time, we're here, able to ponder these mysteries and marvel at the beauty of the universe. The Big Bang Theory also reminds us of the power of human curiosity and intellect. We, insignificant creatures on a small planet, have managed to unravel some of the universe's deepest secrets. We've peered back almost to the dawn of time itself, and are constantly pushing the boundaries of our understanding. The Big Bang Theory provides a fascinating glimpse into our cosmic roots and our future destiny. So this is the end. I hope you enjoyed today's video, and I will see you again tomorrow. Peace.